Howdy, this is Andrea, and in this video we're going to be talking about parallel and perpendicular lines. All right, so let's get into some information about each one. Parallel lines, of course, anything that is parallel, a line that's parallel to the other, runs exactly at the same distance. Those two lines we know will never cross, right? So they have the same slope. That would actually make sense. They do, though, have different y-intercepts, and we can easily, excuse me, we can easily show that just by creating a graph here. And let's say we've got one line, going this direction here, and we have another line that's parallel to it. Of course, it has to be in a different spot on that y-intercept. Otherwise, it would be exactly the same line. If this pink line was moved up and had exactly the same y-intercept as the black line, it would be exactly the same line. So we need different slope, or excuse me, same slope, but different y-intercept. So when finding an equation of a line that is parallel to another, we have just a couple of easy steps. Of course, if the slope is the same, we can use the same slope as the original. And then they will always give you 1 point. And they're basically saying that this point, whatever it is, x and y, let's say it's right there, is on that line, right? It's on that new line. So we plug the x and y in, and we're going to just solve for b. And then we've got our new equation. Okay, so that's actually nice and straightforward. Now, perpendicular line, of course, anything that's perpendicular just means it comes, oops, that is not what I wanted. It crosses at a 90-degree angle, right? It's got this 90-degree angle in here. Okay, so what we know about the slope of a perpendicular line in comparison to an original is that it has the negative reciprocal. Okay, and what that really means is negative, I kind of like the word opposite here, the opposite reciprocal, because sometimes when it says negative, it makes students think that it's always a negative value, but it's really the opposite sign. Okay, that's kind of what that means, opposite sign, and then reciprocal. Reciprocal just means the flip of the fraction. Okay, so we flip the fraction, change the sign. And so it's the same sort of thing. We actually look at the original slope, and we're going to take the opposite reciprocal or negative reciprocal of that original slope. They're also going to give us a point on that new line, so we're going to just plug that in and solve for b. Okay, so let's do a little investigating here just to see if we can find these slopes of parallel and perpendicular lines. We know that, at least in this class, for the purposes of this class, we're always going to be talking about the slope-intercept form, y is equal to mx plus b. So in these first few problems, we're really just looking for what is in that m position, right? And we want to make sure that it is written in this standard form before we make that decision. Because if it's not written in the standard form, then, for example, like question number 2, it's a little bit harder to figure out what m is. So we're always going to make sure that we rewrite this in standard form first to find that slope. In question number 1, we can see that the 2 is in that position. It's already in standard form. So a slope of a parallel line to this original would be 2 as well. It's the same slope. In question number 2, we just have a teeny bit of work to do. We need to rewrite this equation so that it is in standard form. So rewrite in standard form. Okay, let's do that. So we want the y on the left, but we want the x's on the right. Okay, so we've got a 3y is equal to negative 12x plus 15. We want to put everything in the right order according to this equation up here. And we're almost there. Gotta make sure we remember that we're dividing the 3 by every single term. Negative 4x plus 5. Okay, so now we can locate that slope, and we know, of course, that the slope would be the same in a parallel line, so we would need a slope of negative 4. All right, let's jump down to question number 4. Now, in these 3 examples, we're looking for a line that's perpendicular versus parallel, which is what we did before, up above here. Question number 4, it's already in standard form. This equation's already in standard form. Here is our original. So if our original m is equal to 5, we need the opposite sign. So here's our whoopsie. Let's try to write that the right way. Our oh my gosh. Well, let's just fix it that way. Perp m. We want to make it negative because this up here is a positive, right? And this is a 5. Well, we can just kind of pretend it's over 1, and we flip that guy over. So our perpendicular slope, instead of being a positive 5 on the original, perpendicular slope is negative 1/5. Okay, let's try it again. So here's our original, negative 1/3. We're first going to flip that over. 3 over 1, and we're going to keep it that way because here we have a negative in our original, so our perpendicular slope that we need is going to be a positive 3 over 1, and we can just call it 3. Okay, you can see in problem number 6, it's not yet in standard form, so we need to make sure that we rewrite this. I'm going to move our x term over to the right. 36y is equal to 4x plus 18. Let's get that 36 out of there. All right, so y is equal to, be careful here, this is 4 over 36. Of course, we can divide both of those by 4, which is going to give us 1 over 9, 1/9 x, and then 18 is half of 36, so plus 1/2. Okay, so if 1/9 is my original, that's my orig, then the slope that I need is going to be the flip of that, 9 over 1 instead of 1 over 9, but we need to make that negative, or we can just simply call that negative 9. Okay, so as you can remember from a lot of the work we've done before, when we are writing the equations of lines, or writing linear equations in the form, slope-intercept form, we are always looking for the m and the b. So these exercises here would help us to learn how to write the m, how to find the m. Okay, so let's do a full problem where we need to find the m and the b. Let's go ahead and, let's see, I think I want to do problem number 7. Let's work on this one. What is the equation of the line that is parallel to 8y plus 6x equals 16 and goes through the point 12, negative 9? Okay, so remember that what they're doing here is they're telling us that this x and y is on the new parallel line that we're trying to find. Okay, and this guy is the original. This is our original line, our original equation. And we're trying to find a new equation for the line that's parallel. All right, so we can see first off, in order to be able to find our m and find our m, I should say, we need to rewrite this guy. So here's my original. 8y plus 6x equals 16. And we're going to move our x terms over to the right. Negative 6x plus 16. Okay, then we need to divide by 8. So y is equal to, and we have negative 6/8, we're going to want to reduce that fraction. Both of those numbers are divisible by 2. So we're going to have a negative 3/4 x plus 2. So here is my original equation. Okay, and remember, when we're trying to find a line that's parallel, we know that our m is the same. So we are already set in our new equation, right? We know that m is going to equal negative 3/4 because we need that same slope as the original. How do we find our b? Well, that's why they give us this point, right? In order to find our b, we need to just plug in. So our m is that, our b, in order to find our b, let's write out our original equation here, an equation with our original slope. We know that this is true, but we don't know anything else yet. We don't know our b. So we're going to just take our two values that are given. Looks like our y is going to be negative 9. Our x over here is 12. We're just plugging those babies in. And we've got a negative 3/4, and I can put this over 1 to make it look a lot easier here. So this is negative 36 divided by 4, right? Or if you prefer, you can just do your cross canceling right off the bat here, right? So we're going to have negative 9 is equal to negative 9 plus b plus 9 plus 9. So our b is equal to 0 here. Okay, so we want to put this together. So b is equal to 0. So our new equation is actually going to be y is equal to negative 3/4 x. And since b is 0, we don't even need to write that, okay? We don't usually write that out. We just stop right here and say, okay, this is my new equation. Okay, and let's, just for grins here, I'm just doing a little sketch here. I'm not gonna actually worry too much about the slope, but I wanna show here on my y, if my original, let's do my original in black. Here's my original equation, right? Here's 2. And actually, maybe I will kind of think about my slope. This is just a sketch, not super accurate. So I can graph this just by plotting my b. Here's my b. And I can take my slope, which is negative 3/4. Now remember, on our slope, it's rise over run, right? So I'm going to go down 3, 1, 2, 3, and over positive 4. So 1, 2, 3, 4. Okay, that was down 1, 2, 3, and over 4. Okay, so here is my original. That's my orig. Okay, and then when let's just use a different color here. Let's use pink for our equation of our line that's parallel to that. When we have an equation where b is 0, what that just really means, guys, is that it's going to cross at the origin, right? And then we have the same slope. So, or excuse me, yeah, same slope. So we're going to go down 3, 1, 2, 3, and over 4, 4. Okay, and if we graph that, we can see indeed we have these two lines that are parallel to each other, but they just cross at different locations on the y-axis. All right, let's take a peek at number 9. So now our job is to find a new equation of a line that is perpendicular to the original line and crosses through at this point here at 6,4. Okay, so we want an equation that has that information, and it's based on the original right here. Okay, all right, so our original we've got y is equal to 3x minus 5. Luckily, it is already in standard form, so we're super happy about that. Our original slope is 3. Therefore, our perpendicular slope needs to be the opposite reciprocal. So we're going to just pretend this is over 1 or put it over 1. So our m is going to be the flip of that, or the reciprocal of that, and we need to stick this negative sign in front because the original was positive. And in order to find our b, remember that we just write out an equation in slope-intercept form using our new slope, and we're going to solve for b. So we want to make sure that we're going to plug in our y and our x. And looks like here our y is 4. Our x is going to be 6. Okay, so we're plugging in for these guys right here. 1 over 3. We could put that over 1 if we choose to, plus b. Okay, 6 divided by 3 is 2. Minus 2, minus 2. Okay, so our b is going to equal 2. Hang on a moment, I made an error, I noticed. I forgot my negative. Negative plus plus. Aha! Oof, be careful, check your work. That's what I needed to do. B is equal to 6. That is better. Okay, so now we can just put this information together over here to write our equation. Y is equal to negative 1/3 x plus 6. Okay, so here's my perpendicular equation. Here is my original equation, and you know, we could show that just for grins. Let's just do that. I know, like I said, I don't have graph paper here, but I can do just a sketch of it down in this location, just so we can kind of get a glimpse of what it might look like. Okay, so I'm going to have my original equation here in black. Let me get some lines on here. Whoopsie. 5, 6. All right, let's go to our y-intercept here on our original, which is at -5. I have to fix this because it's hard to see. Sorry, guys. 1, 2, 3, 4, 5, 6. There we go. So we cross at -5. Here's our y-intercept. We have a slope of 3, so it's up 3 basically, and over 1, up 3 over 1. So we're going to go 1, 2, 3, 1. Can even do it again if we want to. We can go 1, 2, 3, 1. Okay, so we've got this line that sort of looks like this. Here's my ridge. Okay, and let's go ahead and graph this line. This is our perpendicular line. So you notice that it crosses at the y-axis at +6. Our slope is -1/3. So what that means is we can either go down 1 on our y and a +3 on our x, or if you chose to, you could go up on your y, but you'd have to go negative on your x. You notice that both of those are going to give you a negative slope. Since I'm way up here on my y-axis, I'm going to choose the first option. I'm going to go down 1 and over 3. I'm sorry, I gotta make my little, I want to make sure that's right. Oh, I shouldn't have done that because I can't really erase this very well. Go to 6, and that's about right there. All right, so if I were to just connect these points with a line, and we can see that this is my perpendicular slope. I keep wanting to put a P there, I don't know why. Okay, but the point is, we can see right here is that 90-degree angle. They meet at that 90-degree angle, and that's what we're expecting to happen. So you guys can always do a little sketch of a graph just to double check yourself and make sure that it looks right. All right, guys, so we in just a little bit here, I'm going to do another video on this problem number 11. So look for that video. We're kind of putting all of this information together into one problem, and this is actually quite an important problem. All right, so we'll see you in the next video. Bye-bye.